Anton. I'm currently the PhD candidate from EC3 Zürich, the economics here. And I'm also working on a project, Stable House. We got two PIs, Professor Daniel Hall and Benjamin Dillenburger. We got like one postdoc researcher, Anton Savov, and two researchers from currently the Professor Jianpeng and me. Now we also have like the two contributing researchers, the Professor Zhang and Professor Diff. So if you look back to the existing work regarding how to make the generative AI in layout generations, we have seen like a lot of work working on allow the user to give the layout graph as constraints and make the final floor plan generations. But we want to ask, is this really necessary? Like, always require the user to always input the complete layout graph? Because sometimes it's common to see like the designers in the early stage, they always come up with the initial design ideas. So in such case, like they might come up with the initial fragments of idea and then keep evolving into the final stage of floor plan generations. And we can also see some examples, like when the designer do the early stage sketch, they normally will not do entire and complete layout graph, but rather than they will have their own corresponding focus part, like maybe in the first figure, they make the focus diagram in the central bathroom surrounding by all the other functional rooms. But there's always some part of the layout they're missing for guidance, which means like the user might want to explore this or leaving the AI to handle like what's going to happen in such case. So in conclusion, like we now want to always require the user to input like the complete layout graph, but rather than some partial free range partial layout graph and allow the AI to autocomplete the remaining part. And I'll give you a brief one. Like this is our previous work working on how to effectively accepting the user partial layout graph guidance, make the complete layout generation from SVPR 2024. And but like the second key point will be the user input is not always bubbles like a layout graph, but it's more like maybe sometimes they prefer to do some natural language speaking, describe their projects, or sometimes they want to do the direct sketch on canvas. And in such case, I mentioned the second prior work, like working on how to allow the user to input the hybrid multimodal design constraints from natural language, from free range of layout graph, and from free sketch. And in such case, like we not only allow the user to input the layout graph, but also like the free user prompt and the direct sketch. And the most important one, the current work I'm going to present, is like how to effectively integrate the practical constraints during the design generations. So in the you see, we have some cool designs. They allow you to do the fully customization, but normally they also require like a lot of time to construct with a huge labor-intensive condition. And in another condition, we have also seen the power of modular designs, and it's like fully standardized with a high level of efficiency regarding the constructions, but it's also come up with a lower level of design flexibility. And there is also like one prior work from our colleague Jianpeng and Zhang. Their analysis how to make sure like when you do the construction, which part of your apartment would be better to be constructed by modules, and all the other part could be constructed by the panels. And in our case, we choose the wet core as a module, because like in the apartment the constructions, the wet core are going to be the most complex part. You need to consider the functional wet cores, water piping, drainage, electricities, waterproofing, or maybe acoustic treatment. And we have also seen like in the conventional ways, the bathroom utility buildings, they normally require the designers and the constructors to make the customization regarding how the bathroom will be embedded in the entire layout. But in our case, we want to make the wet core module to be compact. So in such case, your bath and the kitchen could be one compact module, and with a compact zone of water, drain, and electricities. So all of the rest part could be fully customized. And in such case, like compared to the previous work, we have seen the power of free-form designs. They have a high level of design flexibility, but with lower construction efficiency. I have seen like the modular house, they have a super high level of construction efficiency, but like they are normally looks like a one box. And in our case, we want to work on the fabrication-aware design systems, which means like we want to make the most complex part to be modularized, benefit from the power of industrialized constructions. But we also want to offer the design freedom for all of the rest part, like your bedroom, your living room, to be constructed by the panels. So in a nutshell, like this research trying to solve the problems like being integrated from the previous work, allow the user to specify the multimodal design constraints, incomplete starting information, but also to integrate the construction constraints. And in our case, we want to construct the entire apartment by this several category of elements, including the interior panels, exterior panels, slabs, and the modules. And in such case, like in such case, like we do not want to confine only one choice of module and only one location for the modules. In that case, we want to make sure, like in the layout generation, there are several modules, like maybe in stock by the industry, and during the generations, like the generator could pick one of the module stock from the industry categories, and all the rest part will be ultimately computed by and constructed by the panel systems. And in our framework, we allow the user, similar to our prior work, we allow the user to specify the free range or partial layout input, but also like we require to input the category of the bath and kitchen modules. And we allow two mode of generation, like design only or fabrication-aware. And for each of the mode, we have like first the image generations and then parsing into the 3D models in Rhino. And also like given that, we could later on to parsing the corresponding panel list and the module type, and in the final stage, we compose them into the main model as an IPC file. In such case, we are training our model working on SDSL, Stable Diffusion XL large, and we did not train the foundation model, but rather than we propose our own modules for control encoder and the model switcher. And in such case, similar to prior work, like this work could also accept the free range of partial graph combined with the user prompt. And in such case, like the layout generator will always giving us such a graph and prompt as a constraints, giving the various of module solutions. And if the user said, okay, I think in the second iteration, I think the first one, the module looks good, I want to freeze and keep this on canvas, you could also make the second round of customization based on freezing the module on site and make all of the following generation respect to this module selection. We have also tested like under the different conditions or partial layout graph from only assign one rooms on the layout or assign 2, 3, 4, and how the model will perform. Like in our case, we see like in our trained model could like precisely follow where the user places the layout graph here. It will always respect your partial guidance, but on the rest part, we leave the freedom for the AI to explore the diverse results based on such condition. We also have the application study regarding like to test the effectiveness of our proposed module. We can see like if we do not integrate the control encoder, then there will be like the pure noise. So which means like the results on the most right is not workable. And with our own improvements based on the foundation model, we can see like the layout generation is more robust, align more well to the user partial input, and fit the modules much better compared to not making this model investments. And I think that's my presentation.